Hi everybody. So we are starting chapter 3, and this is probably the most intense chapter in the entire course, certainly from a mathematical point of view, because we'll be talking about probability and we will be talking about counting techniques and combinatorics. Okay, and you really can't do much in statistics without those two concepts. So maybe you had some idea of what probability is. Basically, it's a numerical value that we associate with the likelihood of something happening, where that number is always between 0 and 1. Okay, instead of 0% and 100%, we use 0 and 1. So probably let's get some terms out of the way, and then we're going to be look at hopefully some very familiar examples. So we have a fancy term for something which is usually pretty unremarkable, maybe. A probability experiment is an action or trial through which specific results are obtained. Usually they're measurements or counts or responses. So this experiment, you probably think of maybe people in white coats in a laboratory. No, nothing like this. It's just simply it's just something where we obtain some counts, measurements, or responses. And then an outcome is the result of a single trial or a probability experiment. And the sample space is a set of all possible outcomes. So what we have is it could be as simple as flipping a coin. Okay, so the sample space would just consist of heads and tails. And in fact, let's just look at the examples that we give you in our notes here. If we're flipping a fair coin, or any coin for that matter, the sample space will denote by S. Just consists of two outcomes, heads or tails, right? In the case we are rolling a fair six-sided die, the sample space would just consist of 1, 2, 3, 4, 5, and 6. Okay. If we're flipping a coin 3 times, then the sample space there would be a little bit more. We're talking about 3 tosses. We're recording 3 tosses. So it could be heads, 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 tails, heads, tails, heads, or heads, tails, tails, or tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. Okay. All right. So there are 8 possible outcomes in this sample space. If we are picking an integer between 1 and 15 inclusive, the sample space, that's pretty clear, right? It's just going to be 1, 2, 3, all the way up to 15. Okay. For example 5, if we're picking one fruit from a bunch of fruits where we have 3 apples, 4 oranges, and 2 bananas. Okay, so what will the possibility of the fruits look like? The one fruit we pick, well, it could be 3 apples. So we could have, and we're going to assume that all these apples are distinct and the oranges and bananas are all distinct. So let's say if the apples are A1, A2, A3, call this apple 1, apple 2, apple 3, and then O1 will be orange 1, orange 2, orange 3, orange 4, and then banana 1 and banana 2. So this would be the sample space of picking one fruit. If we are picking 2 children from a group of 2 girls and 3 boys, obviously we're going to assume the girls are distinct and the boys are distinct. What would be the outcomes? Well, let's just write these out. Let's say if we could have, you'll see that there's only, if we pick 2 children, there's only one case where we get both girls, so G1 and G2. And let's say if we all go with all the other pairs with G1 in them, G1, B1, G2, B2, G3, B3, and then or I'm sorry, this should be 1, and this should be 1. And then we could have G2, B1, G2, B2, G2, B3, and then we could have B1, B2, B1, B3, and B2, B3. Okay, we're not really concerned about the order of this. We'll consider G1, G2 is the same as G2, G1, so we're not going to be concerned about the order. We're just taking, two children. We're not ordering them. So this would be all the possible pairs that we could pick from a group of 2 girls and 3 boys. Okay, and we can see that there are 10 possibilities, and we're going to see later on there's a nice formula to count the number of possibilities. You don't have to write them out. So this would be the sample size here. For example 7, if we are rolling 2 fair 6-sided die, what would be the outcomes? Well, we can record each outcome with a pair of numbers, the number being for the first die and 1 for the second die. So we would have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Okay, and then we could continue and write all these others. We'd have 2, 1, 2, 2, and so on. And okay, and so here they are. If you want to write these all down by yourself, you can of course pause the video. But you can see that there are exactly 36 outcomes. Okay, we consider one ordered pair as a single outcome, right? Because basically we're rolling one single roll of 2 dice consists of 1 outcome. Okay, so we have to record both rolls, and so we can see that there are 36 possible outcomes here. Okay, and so this would be our sample space here. And then, of course, for the last one, picking an integer between 1 and 100 inclusive is like we did before with 15. The sample space would just consist of 1, 2, 3, all the way up to 100. Okay. All right. So that would be that's the sample space, these outcomes. And now, what do we do with this? Well, what we really want to talk about is we want to calculate the probability or the likelihood of either an outcome or a subset of outcomes happening. We say an event is simply a subset of a sample space, and the probability is a numerical description of the likelihood of an event. Okay, this is like not an official definition of probability, but kind of like a practical explanation of what it's supposed to measure. So what we're going to do now is we're going to assume, give a formula for calculating the probability, assuming all outcomes are equally likely. So if all outcomes are equally likely, so in the case of flipping a coin, we're assuming that this coin is fair and not biased, all right? If all outcomes are equally likely and E is an event, and remember E is a subset of the sample space, then the classical probability of E is just the number of outcomes in E, that is the number of outcomes in which E can happen, divided by the total number of outcomes in the sample space, or if you will, the size of the sample space. So if those of you who are familiar with set theory notation, this would just be the size of E divided by the size of S, size of the event divided by the size of the sample space. And because this numerator is always less than or equal to the denominator, the probability is always going to be between 0 and 1. It can't be any bigger than 1, and it can't be any less than 0. It would be incorrect to say that, let's say, the probability is 30% of some events, 30%. No, instead we would say the probability is 0.3 or 0.3. Okay. So the complement of E prime is the set of all outcomes that are not in E. And not surprisingly, we can see that the probability of E prime is 1 minus the probability of E. So in the way you can see that is, well, if you have if you take these two fractions, and what this basically reflects is the probability of E plus the probability of E prime is equal to 1, because you're taking all the outcomes in E plus all the outcomes that are not in E. Well, those are all the outcomes of the sample space. So the number of outcomes in which E happens plus the number of outcomes in which E prime happens is equal to the number of outcomes in the sample space. So you'll get when you add these two numbers, you get a fraction where the numerator and denominator are equal. So that's 1. All right. So let's do some examples here. We can see that in the simple case of flipping a coin, the probability of a head would just be, this is basically the probability of H. Okay, and so this would just be the number of ways that H happens. Well, that's just one outcome, right? So it's 1, and the total number, the size of the sample space is 2. So the probability would be 1/2. Okay, and same thing here for the probability of tails. That would be the probability of T. That would also be 1/2. As probably a lot of you already guessed that. If we wanted to talk about in our next example of rolling a fair 6-sided die, if we wanted to talk about the probability of rolling, let's say, a 4. Okay, well, 4 is just one outcome out of 6, so the probability of that would be 1/6. Okay, the probability of, let's say, 1 and 5, and when we write this, it's the same thing of rolling a 1 or a 5. This event consists of 2 outcomes. 2 divided by 6 is 2/6, which reduces to 1/3. If we wanted to talk about the probability of rolling an even number, okay, well, the even numbers are 2, 4, and 6. This would be 2 or 4 or 6. There are 3 outcomes, so this would be 3 out of 6 or 1/2. Okay. All right. And similarly, you can see the probability of rolling an odd number. That would be 1/2 as well. Let's say flipping a fair coin 3 times. See, what's the probability of 3 heads? Well, there's only one outcome, and we get 3 heads. So we have 1 out of 8 outcome. 1 out of 8 comes satisfy this. So this would be 1/8. Okay. If we wanted to find the probability of exactly 2 heads, we can see that there are 3 outcomes, right, where we have exactly 2 heads. Here, here, and here, right? So that would be 1, 2, 3. So this would be 3/8. And by the way, this would also be the probability of 1 tail, right? Okay. Okay. So, sorry, I had to leave you for a moment. So this is actually the same thing as exactly 1 tail. If we wanted to talk about the probability of 1 head, this would also be 3/8, because 1 head occurs here, here, and here. And of course, the probability of no heads would be 1/8 as well. Okay. All right. And this would also be the same thing. This would be the same thing as 3 tails. And this would be the probability of 2 tails. Okay. All right. Again, the 8's come from the fact that this is the size of the sample space. All right. Picking an integer between 1 and 15. Okay, well, what can we talk about? Well, obviously, we can talk about the probability of picking, let's say, a 7. 7 occurs exactly once in here, so it's just one specific outcome, so that'd be 1 out of 15. If we wanted to talk about the probability that our number, our integer, is, let's say, divisible by 2, in other words, it's even. Okay, what would this be? Well, what are all the even numbers in here? We have 2, 4, 6, 8, 10, 12, and 14, right? So we have 1, 2, 3, 4, 5, 6, 7. So the probability that it's divisible by 2, that would be 7 out of 15. Okay. By the way, the integer, by integer we mean a whole number, okay, not a fraction. Okay, if we wanted to find the probability that the integer, let's say, is greater than, let's say, 11. Okay, well, what integers are greater than 11 in here? It would just be 12, 13, 14, and 15, right? 4 outcomes. The probability of that would be 4/15. Okay. All right. If we want to talk about the probability, let's say, of picking picking an apple, in this case, picking one fruit, what's the probability of an apple? We can see that there are 3 outcomes where we get an apple, so there are 9. There are 9 total outcomes, right? So this would be 3 out of 9, which of course reduces to 1/3. The probability of picking an orange. Now there are 4 oranges, so that would be 4 out of 9, 4/9. Probability of a banana. That would be 2/9. And we can talk about some other subsets. Let's say if we want to talk about the probability of an apple or a banana. That would be 1, 2, 3, 4, 5 possibilities that we either pick an apple or a banana. So this would be 5/9. Okay. All right. If we wanted to talk about picking 2 children from a group of 2 girls and 2 boys, obviously if we want to talk about the probability of picking exactly 2 girls, well, there's only one outcome in which this happens, right? 1 out of 10. If we want to talk about the probability of 2 boys, this would be, there are 3 cases in which that happens, here, here, and here. So that would be 3/10. Okay, and if we want to talk about the probability of, 1 boy and 1 girl, that would be, let's see, well, it'd be 1, 2, 3, 4, 5, 6. So that would be 6 out of 10, right? And by the way, the complement, let's say the complement of 2 girls would not be 2 boys. The complement would be 2 girls, or the complement of 2 girls would be 2 boys or a boy and a girl. Okay. For example, if we wanted to talk about the complement of this event, the complement would be all these other things. Okay. So we could say maybe the probability of the complement of 2 girls would be 9/10. And of course that would be 1/10 plus 9/10 is 1. Right? If we wanted to talk about the probability of the first girl being picked, we can see there's 1, 2, 3, 4 ways that can happen. So that would be 4/10. Okay. And by this, I mean, the girl 1 is one of the 2 children picked. Okay. Okay. So rolling a fair six-sided die, that is, and those of you who play, if you ever played craps, you probably know about some of the probabilities here. One of the many ways you can play craps is you roll two die and bet on what the sum would be. Okay. Sorry for the interruption again. So yes, we were talking about craps, and yeah. So one of the things that you can talk about is, you roll the dice and you bet what the sum will be. If you haven't played craps, don't start. Okay. I spent too much time at casinos, a few years ago. So just saying, don't start. And we'll talk about later what a terrible game those casinos have in case of your chances of winning. But let's say if we wanted to find probability that the sum is equal to 7, which is actually the most likely sum, the probability is how many ways can you get the sum of 7? Well, you could have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. Okay? So these are basically 6 outcomes, right? 6 outcomes where the sum is 7. And there are 36 possible outcomes, so this would be 6 out of 36, which is 1/6. And the casinos know that. Okay, that's why they adjust the payouts accordingly to that. If you wanted to find the probability that the sum was 4, it's much less likely. Where the outcomes where the sum is 4, well, you could have 1 and 3, 2 and 2, or 3 and 1. Okay, so there are 3 outcomes where that can happen. So this would be 3 out of 36, or 1/12. Okay. Okay. And there are some other ways, but as you can see, we don't have enough room to do any more examples. I would say maybe try and check what the you want probability that both are even. You might think that would be 1/2, but actually it's not, right? You can see how many where both are even. Well, none of them are here. We have 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be only 9 out of 36, or 1/4. And then finally, picking an integer between 1 and 200, or 100. I think there's not much to do here. Let's say if you wanted to find the probability of that this number is, or the integer is, let's say, less than or equal to 73. Well, this would just be this would just consist of all the numbers 1, 2, up to 73. So that would be 73 out of 100. If we wanted to find the probability that the integer was, let's say, greater than 73, strictly greater than 73, that would start with 74, 75, all the way up to 100. Okay, so that would be actually, well, you can see that would be the complement of this, right? So you could count all of these, and you'll see that there would be 27. Okay, or you could recognize that this is the complement of this, right? The integer is either going to be less than or equal to 73 or greater than 73. Okay, so you could actually just calculate 1 minus 73 over 100, and this would be the same as 100 over 100 minus 73 over 100, which would be 27 over 100. Okay. And then finally, if let's say you wanted to find the probability that the integer is divisible by 6, let's say, you'd have to find out, okay, well, what are all the multiples of 6 between 1 and 100? Well, you'd have 6, 12, 18, and it turns out that it all goes all the way, the last multiple of 6, which is less than 100, is 96. And this, it turns out, this is 16 times 6. This is 16 times 1, or rather, this is 6 times 1, or I'll say, yeah, or 1 times 6. This is 2 times 6. So we have these multiples all the way up to 16 times 6. So there's 16 multiples of these here. So the probability would be 16 over 100. All right. So there was a lot to digest in this video. Okay, and there's more to come. In the next video, we'll be talking about counting techniques. So just try to digest this, think about this, and then I'll see you next time.